The number of dollars per month it costs you to own and operate a car and the number of kilometers per month you drive it have a linear relationship. Based on information in an issue of Time magazine, it costs $366 per month to own and operate a car when it is driven 300 kilometers. And it costs $510 per month to own and operate a car when it is driven 1,500 kilometers. Write a linear equation to model the relationship between cost y and distance x. Use your equation to determine how many kilometers a person drives per month if the monthly cost is $450. Alright, so let's go over our steps. Step 1, we need to create two ordered pairs from the data. Alright, so let's look at what we were given. It cost $366 per month to own and operate the car when it was driven 300 kilometers. So our x value is distance and our y value is cost. So our ordered pair is going to be distance comma cost. So out of these two numbers, 366 and 300, I get the ordered pair 300 comma 366. Right, let's do the other one. $510 per month when it's driven 1,500 kilometers. So my next distance is 1,500 and the cost is 510. So I have x1, y1, x2, y2. So I am done with step 1. Alright, step 2 is just to remind us to use the formula y equals mx plus b, because this is going to be crucial when we go to write our final equation and come up with our answer. Step 3, determine the rate m. Remember, rate is just another word for slope, by calculating change in y by the change in x. So our slope formula is y2 minus y1 over x2 minus x1. So y2 is 510 minus y1, which is 366, and x2 is 1,500 minus x1, which is 300. This gives me 144 over 1,200. Now let's reduce this. I just want to get a simplified fraction. I can see these are both divisible by 12. You can see that right away. So this is 12 over 100, but I can keep going. Those are both divisible by 4. So I can say my slope is 3/25, because that's as far down as I can take it in terms of a fraction. Or if I want to turn that into a decimal, I can say 0.12. So we're going to say my slope is 3 over 25, which is the same as 0.12. Alright, so now that we know what the slope is, let's talk about what that slope means. And is it better to leave the slope, in this case, in fraction form, or do we want to leave it as a decimal? And if you're wondering where the 0.12 came from, I just divided. 3 divided by 25 gives me 0.12. Alright, before we move on to the next step, let's take a second and write down what the slope means. So we found the slope, but let's talk about what that slope means. So if I think of it as 3 over 25, remember y is on top, x is on the bottom. And if you remember from our problem, y is cost and x was kilometers. So these are both positive, so they're both increasing. So one way I could write this is I could say for every 25 kilometers driven, the cost to own and operate the car increases by $3. Okay, so that's one way to say it. For every 25 kilometers driven, the cost to own and operate the car increases by $3. Now that's correct, that's factual information, it just might not be the best way to present it. So let's look at the decimal version of the slope. Instead of 3 over 25, let's look at 0.12. Now, I can put 0.12 over 1. Even though it's a decimal, I can still put it over 1. I can put anything over 1. Okay, this is still y and x, so this is still cost, and this is still kilometer. But now what we have here is a unit rate. Instead of 3 for 25, I know how much it is just for 1 kilometer, which sometimes is the best way to present the information. So this tells me that for each kilometer driven, the cost increases by 12 cents. Or you can say it's 12 cents per kilometer. That's a true rate. That's a unit rate, 12 cents per kilometer. So either one's correct. Sometimes you just look at the situation though and decide what's better. I don't have to graph this. So if I were to graph it, the 3 over 25 might be more helpful because I could go up 3 boxes over 25 or up 3 units over 25 units. The 0.12 would be a little harder to graph. It'd be harder to go up 0.12 over 1. But in terms of the situation and we want to know what it stands for, this unit rate is probably more helpful than the 3 over 25. But either way, they're both correct. Alright, step 4 says pick one of your ordered pairs, substitute x, y, and m into the equation, and solve for b. So at this point, we know the slope, and we know 2 points on the line. The only thing we don't know is the y-intercept. We just don't know where it's going to be crossing, where it's going to cross the y-axis. Alright, so let's figure that out. So it says pick one ordered pair, so I'm just going to choose the first one. Doesn't really matter which one I pick. That gives me an x and a y. And I'm going to use the 0.12 when I plug it into the formula. So I have an x, a y, and an m. So I have y equals mx plus b. So y is 366, m is 0.12, x is 300, and plus b. So the 366 went in for the y, 300 went in for the x, 300 went in for the x, and the 0.12 went in for the m. So 366 equals 0.12 times 300 plus b, so that's 36. So 366 equals 36 plus b. Subtract 36 from both sides, and we get 330. So b equals $330. So now I'm going to take these two, slope, y-intercept, and that's going to get me my equation. Alright, so we've done step 4. Pick one of your ordered pairs, and we solved for b. And now step 5 says rewrite your new equation substituting in the values you found for m and b. So we have, in general, we have y equals mx plus b. So this becomes y equals 0.12x plus b, which is 330. So y equals 0.12x plus 330. And this is the equation. The y and the x stay there as part of the equation. The slope is always going to be 0.12, the y-intercept is always going to be 330, but the reason why y and x are variables is because they can change. I can plug in different amounts of kilometers to figure out the cost, or vice versa. Let's say I knew the cost, I could plug in the cost to figure out the amount of kilometers. So we don't want to put numbers in for y and x until we're making a prediction. Okay, so we wrote our new equation. Step 6 says determine if you're solving for x or y and make your prediction. So let's go back up to the question. It says use your equation to determine how many kilometers a person drives if the monthly cost is $4.50. Well, $4.50 is a y value. So in step 6, I have to find x when y equals 450. So you have to make sure, are you plugging in for x or are you plugging in for y? In this case, they gave us a cost, which is a y value, and I have to figure out the kilometers. So I'm going to plug into my equation. So here's my equation right here. So I'm going to replace y with 450. So equals 0.12x plus 330. So subtract 330 from both sides. So I get 120 equals 0.12x. And I'm going to divide and I get 1,000. So I divided both sides by 0.12 and I get x equals 1,000. So number 6, determine if you're solving for x or y. We made our prediction and now we just need to write our conclusion as a complete sentence. So what that means is for a monthly cost of $450, a person drives 1,000 kilometers. Alright, so that was all the steps. We did it all. Now, like I said in class, it seems like there's a lot of steps here, but it just takes practice, and after you do it again, you'll start to notice the pattern. So basically, let's just kind of recap what we did here. Right away, we should recognize we're given two ordered pairs. We see these four numbers here. Naturally, they pair up, okay? There's your 2 points. As soon as you know that you have 2 points, you should automatically be thinking, hey, I can calculate the slope since I know those 2 points, okay? Well, once you have the slope, the only other thing you need is the y-intercept. So you use the slope formula to get the slope, and then plug back into the equation to get the b. And then once you've got both of those, you've got your equation. Once you have your equation, you can make all the predictions you want. So once you get your base equation set up, you can plug in either for y or for x to find the other one. Alright, so really quick, I know this isn't part of the question, but let's kind of, let's graph it real quick. Just draw a rough sketch. We're not going to, make it all fancy because it's not part of the question, and I just want to make sure that you guys have a visual idea of what's going on here. Alright, so there's our equation. Remember, x is kilometers, y is cost, and in this case I only need the first quadrant because my b value is positive, so my b value is up here, so we'll say this is 330. Again, I'm not worrying too much about how exact my graph is. And it increases 0.12, you go up 0.12 for every over 1 that you go. So basically you're going up 12 cents on the cost axis to go over 1 on the kilometer axis. So you're only going up 0.12, so it's increasing, not very steep though. So it's increasing, it's just not a very steep increase. So basically, let's look at this here though. Let's talk about what this means. In class, we talked about how in the other example, the y-intercept didn't really make sense when we had a y-intercept of negative 50. But in this case, this makes sense. This says if you drive 0 kilometers, your cost to own and operate the car is $330. Well, that makes sense, right? Let's say you have a car payment. Let's say your car payment's $330 a month, but your car just sits in the garage and you never drive it. You're still paying $330 a month, even though you're not driving it. Then from there, the more you drive it, the more it costs to operate it. Gas, maintenance, things like that. So in this case, the y-intercept makes sense. Okay, let's look at what we found. We found for $450, a person drives 1,000 kilometers. So let's say 1,000 is out here. If we go up to meet the graph, that means 450 would be about there somewhere. So that would just be another point on the graph.